I can rewrite negative exponents as positive exponents. Why do we even care about this? Well, exponential expressions can never have a negative exponent for the final answer. And I always try to relate it to something that you know from previous lessons in math. Let's look back to what you used to do in 5th and 6th grade. Do you remember when you would have an answer like 50 over 100 or 50 100ths? Your teachers would say, well, yes, it is correct, but you're not finished yet. And it's that key phrase, you're not finished yet, is what I'd like to focus on, because then they would say you'd have to simplify the fraction, or you'd have to reduce it to the lowest terms, and it would be 1/2. Well, when we look at negative exponents, after you go through and you simplify the expression, sometimes you're going to have a negative exponent. And you could come through and do all of the proper work, and you could have w to the negative second power. But you cannot let that be your final answer. We have to take this negative exponent and change it to a positive exponent. That way it obeys this little rule that we've got here of exponential expressions can never have negative exponents for a final answer. So let's take a look at a little story that I've put together here to kind of help explain the steps. It doesn't explain why, but it helps explain the steps. Let's just say that we had 6 living in their house one day, and they were not happy. So we'll make it a negative exponent there. The exponent's not important. It's the fact that it's a negative exponent that you would say 6 is not happy. Well, over here, their parents lived in another house, and they saw that their kid was not happy. So they said, you know what, how about you move into our basement? And then you can be happy. Now, do you see how the exponent went from negative to positive? Well, that's literally how we're going to make a negative exponent into a positive exponent. And it's the same thing as 1 over what's 6 squared? 6 times 6, so it's 36. That's the process. That's the steps without trying to think about it too much. Let's go through and clear this off and give you a few other examples of how this works. Let's just say we have x to the negative 100th power. Well, X is living in their own house and they're not happy. And so basically, if he could just move back in with his parents, he could be happy. Do you see that? He moved into his parents' house. One, we could say, was the parents' house. And let's talk about a few other things. The 1 here has its exponent, and it's an invisible 1. Is it positive? Yeah. So the parents don't need to change their position. It's only the negative exponents, this x, that was so unhappy. Now, let's go through and let's change this. How about if we had 2 to the negative 3rd power? Well, it's unhappy, so move it into its parents' house, and suddenly this unhappy exponent is going to become happy. This is not math terminology. It's just something to try to get you to see the story of going, you know what, it's not happy. Let's just move it into his parents' house. And it goes from a negative exponent, which we would associate with it being sad, to suddenly it's a positive exponent where we go, it's happy. So if I say make it happy on this video, I'm saying take the negative exponents and make it into a positive exponent. This doesn't cover all the examples that we need to get into though. What if we had somebody that was living in their parents' basement and they were not happy? Maybe they were scared of the dark. Well, that x is to the negative 2nd power, and that's a number 1 that's on top. How could we go through and make it happy? Move it upstairs. And so now this becomes x to the 2nd power. This power goes from negative to being positive. That 1 is still there. In fact, you could even write a 1, but do we really need to write a 1 that's going to multiply x to the 2nd power? What's 1 times x to the 2nd power? X to the 2nd power. If you're wondering where the basement went, it's still there, you know. It's just there's nothing down there now. You could put a 1 for a placeholder, but that could get a little confusing, and there's no need to do that. So the basement is still there. The bottom part of the fraction is still there. It's just we don't need to see it because there's nothing else that's really there. So when we go to work with these types of scenarios, let's take a look at this one. Let's just say we have m to the 6th on top, and let's just say that we have n to the negative 3rd on the bottom. what the story is trying to set it up to is this. If there's a negative exponent, you basically need to move it to a different level to make it happy. But if it's a positive exponent, you keep it exactly where it needs to be. See, this n to the negative third is not happy at all. So let's just move him upstairs with that m. The m is happy, so it's going to stay exactly where it's at. But this n, once we move it upstairs, suddenly, oh, the sunshine on his face. So much happier now. And that's all that we do to take these negative exponents to make them into positive exponents. Let's take a look at 3 examples that I've got. This is the part I would want you to write in your notes now. X to the negative second power. Well, put a 1 over it to be a placeholder for on top, and we just slide this x to the negative second to the bottom, but we make that negative second power into a positive, and we're done. Here, this 5 to the negative third power has got a negative exponent. The m has an exponent of positive 2, so the m needs to stay exactly where it's at. But this 5 to the negative third, not happy at all. Move it downstairs. And what about this one? You've got, w to the negative 6 that's in the basement. This 1 is completely happy because it's got a positive exponent. Well, it just needs to move out. Basically we've moved it up, but there's no reason to write that positive 1 in front of it, because if it's a 1, it's just a placeholder. 1 times w to the 6th is still w to the 6th. How about we take a look at these right here, 4 to the negative second. Well, that'd be 1 over 4 to the second. Here's your basic rule too. If you're needing to find a generalized rule that can handle all these different scenarios, if the exponent is negative, move its base and exponent to a different level. So if it's up top, move it down below, and change to a positive exponent. So we're going to change this exponent to a positive. Everything else stays. So what about this? 5 to the negative second is not happy, so we need to move the base and its exponent to a different level. Let's move it upstairs. And because that's a 1, there's really no need to write 1 times 5, right? So we'll just take that off of there. How about this one? 16 has its own exponent. That's 1. So the 16 is going to stay. It's the g to the negative 8th that's got the negative exponent. That's what's going to be moved down below and change the exponent to a positive. What about this one? What's the exponent for the x? 1, so the x stays. What about the 4? Well, that's got an exponent of positive 1, so that 4 stays. It's happy where it's at. What about this y to the negative third? That's the unhappy one. We need to pop it upstairs. Y to the third, move the base and its exponent and change the exponent to a positive. And then z to the fourth, hey, it's happy downstairs. So z to the fourth. That's how we do those. Here's a practice and check page for you. It's got 3 problems, I believe. Yeah. So go through, pause the video, answer these. Here's your basic rule of thumb for handling these if you need it. Hit play when you're ready. Here we go. This should be 1 over p to the third. There should be, because the x has a positive exponent, the x needs to stay there. The 3 to the negative 8th goes up, so that would be times 3 to the 8th power. You don't have to worry about it right now. If this is your first attempt, if you got this, you're fine. However, usually you would put 3 to the 8th in the front and the x in the back. The variables are always in the back. And that's just kind of more of a math courtesy, proper formatting. And here we go, 21. The 8 is positive, the m is positive, the n is not positive. So the 8 and m to the fourth stay exactly where they're at. We just move the n to the 5th down below, and now it's happy, and you're set up for it. Well, that's been about 10 minutes of trying to explain how you change a negative exponent to a positive exponent. And let's go back and look at y. Exponential expressions can never have negative exponents for the final answer. Okay, for the final answer. So this is how it applies to what we've learned so far. You can simplify exponential expressions with negative exponents following the same rules that we've always followed. X to the negative fourth times x to the negative fourth would be x to the negative eighth. Why? We have the same base and they're multiplying each other, so we add the exponents. Well, all those rules that we learned about adding and subtracting integers and multiplying integers, they come into play here. A negative plus a negative is still negative. We just add the two numbers together and keep the same sign, so it's negative 8. However, we know that this cannot be our final answer. It can't have a negative exponent. So now we just make it into a positive exponent and we're done. This right here, same base, they're multiplying each other, add your exponents. So 5 to the negative 6th. Do a quick check to see if you have a negative exponent. You do, so just make it positive. Right here, when it's a power raised to another power, we take the outside exponent and we multiply every exponent on the inside by the outside exponent. So 1 times negative 3 is negative 3. Negative 3 times positive 5 is negative 15. Make sure that you don't have any negative exponents. If you do, take care of it. There we go. And just a quick reminder, every rule still comes into play. A negative times a negative is positive. So that's 9 to the 16th power. And a negative times a positive is a negative, so that's x to the negative 32nd power. Quickly do a quick check to see if you have any negative exponents. Since the 9's exponent of 16 is positive, that's fine. We don't have to do anything about that one. However, the x has the negative exponent. Just slide it down to a different level and then change, let me fix that, and then change the exponent from negative to positive.